Hello, everyone. This is Rick from Neo, and here we are again recording another episode for our podcast. And tonight I've got a wonderful guest from all the way over in Greece. It's the ever so lovely Chris Gioran. Hi, Chris.
Hi, Rick.
Hey, good to have you on the podcast.
It's good to be here.
Yes, absolutely. So, Chris, most people won't know you, at least not, they might know your work, but they may not know you as a person. So, would you mind introducing yourself?
Sure. So I'm Chris Gioran. I come from Athens, Greece. I'm a software engineer, and I have been in the boiler room of Neo4j, working in the kernel, deep within, very close to the disk, for the past 4 years. 4 years and something now.
Wow.
Yeah, I've been in the kernel team since pretty much the beginning.
Wow.
And I've also moved over occasionally to the AJ component, and I'm currently one of the two primary authors of the current AJ offering when we moved from Zookeeper to AJ, to Paxos, basically.
Cool. Hey, Chris, and how did you get to Neo4j? Can you tell us a little bit of the history there?
Yeah, sure. So when I was fresh out of university, one of my primary research interests was databases as an undergraduate, and I worked a bit in the industry, working as a database optimizer, I guess. I was working with relational databases, trying to make them work faster, especially because most of the ORM solutions, like object to relational mapping solutions that people use to create websites, are not that efficient with the SQL they produce. So, yeah, and being into databases, being really into software engineering in Java, I started looking into the NoSQL solutions that were popping up at that time. And Neo4j drew my attention because it was written in Java, and it was, and it still is, of course, a true ACID database. And I really wanted to get into the actual implementation of the thing instead of just being a user. So I started reading the source code, and I wrote a series of articles describing how Neo4j manages its transactional aspects, how it stores information to the disk, how it ensures locking, isolation, all the good things that we've come to expect from databases.
But you were not working for Neo at the time, right? You were just
No,
a
no.
community member, right?
I was just a community member.
Yeah.
If even that, I was just a guy interested in how it works, basically.
Very cool.
So yeah, I wrote those articles, and Peter Neubauer basically picked them up along with the rest of the team, which was very young at the time, and we got to talking about it. I got the opportunity to write some code. Basically, it was around getting external transaction managers to work with Neo4j so that you can have real two-phase commits between, for example, Neo4j and another database like MySQL. And we integrated that into the kernel, and yeah, as they say, everything is history after that.
Yes, the rest is history, absolutely. So, and then you started working for Neo, as a software engineer. What were some of the main things that you worked on? You mentioned the HA implementation, right?
Yeah, so like I said, I started off working in the kernel, basically. So my first big task was moving into the new property store that we use right now, which is more compressed than the original versions of Neo, taking up less space, and it's also more efficient because it takes up less memory, and you can read more from disk with one go. After that, though, I started moving into AJ, and initially I tried to optimize the way that we used Zookeeper to make like big cluster offerings work more efficiently. Yeah. But then we saw the shortcomings of that approach, and me and Richard Oberg, basically, we got down and we rewrote the way that AJ works, and we moved away from Zookeeper, which, great software as it may be, it wasn't fit for our purpose. And we wrote from scratch a Paxos implementation, which does pretty much the same thing, but in a much more controlled fashion, and a way that we can debug it and maintain it and make it far more performant.
And Paxos, Chris, just so for our listeners,
right.
Paxos, that's a protocol, right? It's a high availability protocol.
Basically, it's a distributed consensus mechanism. It's one of the primary protocols used for atomic broadcast, and in simple words, it means that it makes sure it makes sure that all the machines in the cluster know exactly the same things, even in the face of partial failures or complete failures.
Okay.
Yeah. and that's
and
what we use.
that's what Neo4j, the current version 2.2 uses, right?
Yes, that's exactly right. Since
Cool.
1.9, basically. 1.9 was had both Zookeeper and AJ as an offering. You could switch between the two, basically,
Hmm.
or close anyway. And but since 2.0, AJ, the current Paxos offering has been the only thing that we use.
Okay, cool. So maybe I can sort of quickly zoom out a little bit. You mentioned that you were interested in databases already, but was there anything specific about the graph model or the graph database model that attracted you to Neo? What was there? What did you like about Neo at the time when you started using it?
My first interest in Neo was mostly the technology behind it. It was a grassroots database that had asset guarantees, and that's what drew me to it. It wasn't the model, to be honest, but very
Yeah.
soon I came to realize, getting involved in all the ecosystem and seeing how people use this, both as community members and as like large deployments that we had at the time,
Yeah.
that even though it was such a small code base and it really wasn't as mature as most of the relational offerings. It offered very similar guarantees, but insanely faster performance. That was the thing that struck me first.
Yeah.
Uh, so it was the lack of joins, basically, right?
Hmm. Yep.
And the other uh, was the lack of impedance mismatch between the object-oriented paradigm of programming
Yeah.
and the way that you store stuff in a graph. Because when you use a relational database, you have a round peg that you try to fit in a square hole,
Yes.
basically.
Yeah.
But when you have a graph, you can map pretty much one-to-one all your domain objects onto the disk, and you will never know the difference. And testament to that has been the Spring framework, right? Which was essentially the effort of just one person, Michael Hunger,
Michael, yeah.
who single-handedly provided an ORM from Spring onto Neo4j. Whereas if you see the solutions for the corresponding relational problem, they are insanely complicated and have
Mhm.
lots of shortcomings.
Yeah. Very cool. Okay, so Chris, where is it going? I mean, maybe we can zoom in on that one a little bit. I know
Mhm.
that you are, taking on some new adventures personally.
Mhm.
You can talk about
That's
that
true.
if you want, but where do you think the graph space or the graph database space is going as well? What's your opinion on that?
Well, judging from the stuff that we have seen that the market wants, like our customers basically, as well as our own research interests and the way that we want to take things, um, I can see that I see two trends basically. One is graph processing, global graph processing. That's something that looks really, really interesting, which is whereas most of the NoSQL solutions right now, perhaps they are better suited for online transaction processing, we also want to move into graph global queries and do like black box processing of very, very, very big graphs.
Yeah.
Um, Provide functionality like a graph compute engine or like huge graphs that you can process really fast and do data mining or do interesting analytics on it.
Like distribution of queries and all those types of things. Is that what you're
So
thinking of?
exactly.
Yeah.
And that actually leads us in nicely to the second thing that I'd like to see, which is really, really big graphs. Right now, there is no real offering for having graphs that are practically unlimited in size. This is something that we are looking into for Neo4j. We've been doing so for a long time, semi-publicly, basically.
Yeah.
Um, and we really want to move into that direction. I'd really like to see clusters of thousands of machines processing huge amounts of data with the ease that we've come to know from Neo4j when it comes to single instance data,
Yeah.
basically. So it's not only performance, it's also the abilities that you gain, the kinds of stuff that you can do very easily when you have that technology.
Okay, very cool. So, Chris, you personally, you're going to do some new interesting adventures, right? Do you want to talk about that, or do you want to mention
Sure.
that, or
Uh, I can talk briefly about it.
yeah,
Apart from my software engineering interests and graphs in particular,
yeah,
I'm also very, very interested in doing some work in journalism.
Okay.
So for the past, I don't know, 2 months, I think, I've been working as a data journalist in a new venture, like an NGO in Athens, Greece, where we
Fantastic.
try to do that sort of work. And currently, I'm the only junior data journalist on staff.
Super.
Uh,
Does it have a name already? Does the agency have a name already?
yeah, it's the name is the Aneosis, which
Okay.
sounds like a Greek word, but it really isn't. I mean, it's not. It's a portmanteau. It's a connection. It's a concatenation of two words from
Okay.
Greek.
Okay.
Um,
I'll put a
and
link. I'll put a link to it on the blog post that goes with the podcast. Maybe a
sure,
good way
when we
to.
launch, because
Yes.
we don't have a site right now.
Okay.
It's We're launching mid-May.
Fantastic.
But that's one of the things, that data journalism is also a domain that can gain from graphs, by the
Yep.
way, and we already have projects starting that will be using Neo4j basically for ontology processing to start with,
Fantastic.
which is, yeah,
Very cool.
exciting.
So, Chris, I think we're going to wrap up. We want to keep these podcasts reasonably short. So, thank you so much for spending the time with me. I really appreciate it. And good luck with your ventures, both at Neo and with your agency. Thank you for coming online, Chris. I appreciate it.
Thank you for having me, Rick. Thank you
And
for doing this, and yeah, thank you for everything, basically.
cheers. Bye.
Cheers.